So we actually discussed star schema in the last class, like what actually star schema. So in general, we do have a fact table, and we have different dimension tables. We may have a number of dimension tables, but in general, the definition of star schema is like a fact table must be directly related with the all the dimension tables. Okay. So we should have a direct joins between fact table and dimension table, which is called as star schema. Okay. So basically, star schema helps a lot for better performance when you compare with Snowflake schema. But I'll tell you why star schema gives a better performance. Okay, I'll showcase the table structures as well. We have to understand what is the table structure of star schema and Snowflake schema. Why do we prefer star schema most of the cases instead of Snowflake schema? So that is what I'm going to showcase now. And as I said, star schema, which is very important for the performance because because of the table structures and a number of joins. So if you have multiple joins, for sure we'll get the performance impact. Okay. But in general, before moving on to Snowflake schema, anyhow, I'll tell you the definition. So we have, okay, let's go with the Snowflake schema, and we'll go through all the basics as well. What actually the primary key and foreign key and unique keys examples. Okay. Snowflake schema definition is a bit different, but let me explain first the definition, and we'll go through the actual topic. So the explanation of Snowflake schema. So a larger dimension table, if a larger dimension table is divided into multiple subdimension tables. Okay. Basically, this concept is called as normalization. If a larger dimension table is divided into multiple subdimension tables, and those dimension tables which are indirectly related to fact table is called Snowflake schema. So basically, this first part of the definition, right? The first part of the definition is called as normalization. So normalization is nothing but in general, in star schema, let's consider one example, like we have time dimension table, right? This is star schema table, correct? So this is a time dimension table. This is not a larger dimension table, but this is a dimension table which is divided into multiple subdimension tables. Okay. So instead of having one dimension table, we may have individual dimension table for individual levels. That is what Snowflake schema. Okay. So let's say we have a fact table. Profit, discount, quantity, and we have other dimensions, as I said, right? I'll tell you. As you know, like we have the lowest level of granularity. But let's say we have time dimension table in star schema. This is just an example. We didn't have this particular table structure to showcase practical example, but I'll showcase the proper example in Snowflake schema with Tableau, right? Okay. So, so we have a time dimension table, which is in star schema, and we have year, quarter, month, day, complete all these levels in one single table. Okay. But normalization is a concept where we have a dimension table which is divided into multiple subdimension tables with the help of primary and foreign keys. Okay. So we have a table, let's say we have day dimension table. Okay. And in that day dimension table, we do have day underscore date, or let's say date column or something like a day ID. Okay. Or let's go for only day underscore date. Okay. One column. And we do have we do have what is the next table? So as I said, we have individual tables. We have a month dimension table. In month table, we have month ID, month name. Okay. In quarter dimension table, we have quarter ID and quarter some date column. Okay. In year dimension table, we have year ID and let's say some year column or year date column. Okay. So let me showcase the same whatever we have, right? So let me showcase practical example. So we have a tutorial data, which is perfect example for Snowflake schema. Let's understand this. Okay. So we have a table called as, we have fact table. I'll come back to fact table. So we have a day dimension table, right? So we have LU underscore day table. Okay. So don't worry about previous day day date, last month day date, last quarter, last year, and all this. Okay, let's leave it. But you have a day date column, right? Understand, right? You have a day date column, and we have month ID, quarter ID, and year ID. Basically from day table it is related to month, quarter, and year, but I will go for proper parent and child relationship. Okay. So I'll try to showcase what exactly the parent and child relationship. So do you know what is parent and what is child? Let's say we have year and quarter. Can you tell me which one is parent and which one is children? Are you getting the point? So we have a concept called as parent and child. I'll tell you in the hierarchies concept in Tableau. But you know which one is parent and which one is children? Something like that. Between year and quarter. So parent and child is nothing but parent and child, relationship is nothing but, so one to many relationship, one to many. So let's say we have 1 year, 2022. In 2022, in general, okay, in any year, how many quarters we do have? Can you hear me?
We have 4.
4 quarters, right? Q1, Q2, Q3, Q4. So 1 year, many quarters, correct? You understand, right? 1 year, many quarters.
Mm-hmm.
So then we do call it as parent and child relationship. That is very important, okay? And for 1 quarter, how many months we do have for Q1?
The 3.
3 months. For every quarter, we have 3 months, correct?
Yep.
So let's understand these are the basics. So try to understand the data. That's the reason I'm explaining these. So when you go through like year, quarter, month, and day, which is like a parent and child relationship. Okay. So 1 year, many quarters, 1 quarter, many months, 1 month, many days.
This.
Okay. So which is a parent and child relationship. Here also the same. When you go back to this tutorial data, so this day date is present in the day dimension table, day date LU underscore day table. If I wants to name it as LU underscore day, I can do that. Okay. LU underscore day. And this is like LU underscore month.
Month.
Exactly. I'm replicating. Okay. LU underscore quarter is a table name. LU underscore year is a table name. So in the LU day dimension table, we have day date, and in the fact table, I'll practically showcase this example in Tableau. Let me close this. In the fact table, do we have any days and day related fact tables? You can see. So this is the fact table, and in the fact table, so we have day date, and we do have call center ID, which this is what we have seen in the last class, right? But we have day date is a common column between day table and the fact table, day date, correct? This one, day date. So let's consider this is a fact table. Day underscore date is a column where present in the fact table, and the same column which is also present in the dimension table. Okay. So this concept basically is called as primary and foreign key relationship. So whatever the parent table, I'll tell you what exactly foreign key and primary key. Okay. Let's say any person, right? Let's say, so I'm from India. Okay. And so let's say if I'm going to visit USA. Okay. So when I visit United States of America, I will become a foreigner to those people, correct? Understand, right? So I
Yeah,
mean,
correct.
yeah, so this is the parent table, this is the actual table, right? And you are the citizen, I mean the main, what is your base location, right? What is the actual location you came from? So you are from India, and you visited United States of America, and you will become a foreigner. Okay, something like that. That's the reason why we do have a foreign key. So primary location and something like a foreign, something like that. Okay. So what is your actual table and why we are going to place this key columns in different tables is like, so to establish relationship between the tables. Okay. So that is the reason why we have a primary key and foreign key. But what actually primary key? Okay. And what is foreign key? And what is unique key? If you have any idea, you can answer. Okay. No issues. What is primary key? What is foreign key? And what is unique? What is unique key? No duplicates, correct?
Yeah, right.
It won't allow any duplicates. Understand, right? So primary key is nothing but it is unique, which is it won't allow any duplicates and not null. Very important. Okay, remember this. Primary key is nothing but it is unique and not null. Okay. Foreign keys like I'll tell you this. Foreign key is like simple subset of primary key. Foreign key is like subset of primary key. Clear all? But let's understand this. I'm going to showcase this example practically in Tableau, which is one of the very good concept I do feel, okay, to understand better relationships. So now we generally learn star schema where we have day ID and day ID present in fact table, and we have a relationship between day table, time dimension table, and fact table. Okay. And we also have a direct relationship between customer table and the fact table. We have customer ID here and customer ID here, correct? And similarly, we have city ID and city ID, product ID and product ID. We do have direct relationship between from fact table to dimension tables, correct? But in Snowflake schema, we don't have a direct relationship. So we have a relationship between fact table and dimension table. Okay. Now, as I said, we have a parent and child relationship. So this month ID, basically they will place in the day table. Okay. This month ID, they will place in the day table to establish relationship between the tables. Understand, right? So month ID is a primary key, which is the actual table, right? In the month table, month ID is the primary key, correct? If I wants to establish like relationship between day table and month, they used month ID, which is a foreign key. Okay. Now have a relationship between day table and month table by making use of what is a common key column between day table and month table. What is a common key column between day table and month table?
Month ID.
Month ID. I'll showcase, as I said, I'll showcase practical, okay? But just concentrate, please. Similarly, to establish relationship between quarter table and month table, which is the primary key, and they will use the same quarter table, like that particular column as a foreign key to establish relationship between, so these two tables. Okay, so I hope I'll try to give another color. Let's see. Yeah. And in between these two, so this year ID is a primary key in the actual table. and I'm going to use the same year ID in the quarter table, which is a foreign key. Understand, right? But as I said, we don't do all these things. Okay. So basically we do get the requirements where what are all the available tables, and we are going to do the data modeling concepts. But I'm going to showcase practical in Tableau, but let's understand. Now it's like we are not going to have month ID in the fact table, quarter ID in the fact table, and year ID in the fact table. We don't have a direct relationship between month to fact table, quarter to fact table, and year to fact table. These are all indirect relationship, correct? So that is whatever the dimension tables which are indirectly related to the fact table is called as snowflake schema. Okay. But understand this, we may have n number of primary keys, n number of unique keys in a table. Okay. We may have a number of unique keys in a table, but we have one primary key for one single table. That is the actual thing, but we may have multiple, depends on the data and the situation. But in general, we have one primary key for one single table. Primary key does not allow null values, and primary key is unique, which is no duplicates. Okay, that is the reason why normalization helps no redundancy. Okay, no duplicated data. So that is what normalized schema. So snowflake schema advantage is like no redundancy, which is no duplicates, no duplicate data. That's the reason why it helps a lot, because if you have primary foreign key relationship, right, you don't have any duplicate data. Okay, so that's advantage. But now let's understand this way. Okay, so let's understand this way. Okay, in the same information, like yes, we have ID columns.
Class, you have to have patience.
So let's understand this way. Okay, so basically we have one single table in star schema, correct? The same information, year or quarter or month or day. So to get the same information in snowflake schema, we have 4 different tables. Understand, right? So if you go back to sheet 5, so how many tables we have to get the same year, quarter, and month and day? We have all individual tables. And let's say in the day table we have, do you remember, like in the day table we have, let me showcase that. Now let's understand this is a fact table. In fact table we have day date, correct? And the next dimension table is LU underscore day. So this one. So in the fact table we have some facts information and day date, and in the day table we have day date, correct? This is a primary key. And in the day table we have month ID. Do we have month ID in the day table? Yes, month ID, which is a foreign key. Okay, we are referring to this particular table to establish relationship between this. And we have other columns as well. Let's no worries about that. Let's go back to month table. We have month ID, month date, month description, month ID, month date or month name. Okay, anything is fine. And what is the foreign key we do have in the month table? Quarter ID, correct? Do we have quarter ID here? Yes. We have quarter ID in the month table, correct? Similarly, in the quarter table, we should have year ID. Okay. We have quarter ID in the quarter table, and we have year ID in the quarter table. Quarter ID and year ID in the quarter table. Similarly, we have year table, correct? LU underscore year. So we have year ID, year date, some duration, year ID and year date. I hope you're getting something, but let me showcase practically in Tableau. Understand, right? So we do have all day, month, quarter, year, all individual tables, just for only for time dimension. And let's say we have geographical information as well, right? There are like region table, right? So, and LU underscore country, customer city, right? Customer state, customer region. So we have all these individual tables. So now, by making use of Tableau, which is one of the easiest and one of the flexible, and you will understand how we are going to establish relationship between the tables. Okay, let me browse documents, my Tableau repository, data sources. We'll have tutorial data. Okay, I'll share these files. I didn't share the files yesterday, sorry for that, but I'll share today. All this, like the coffee chain, tutorial data, everything. Okay, this is the 100 MB file. I'll share you the drive. Yeah, it's not an issue. So what is the fact table we are referring to? Day center sales, right? Correct. So fact table is like a day center sales, correct? Do we have day center sales? Yes, correct. This one. Clear all? So I'm referring to the fact table. So I'm going to pull day center sales into Tableau. Please let me know if you have any questions, okay? Any questions? And I'll tell you how to connect everything. So not an issue. So I connected to Microsoft Access. This is not Tableau related database, but this is an MS Access and which is a Snowflake data model schema. You can drag and drop other tables, but it won't allow with the kind of table structure. You have to double click on top of this table. Okay. So what is the next table we have relationship between fact table to the dimension table? What is the dimension table we have relationship? Do we have any relationship between fact table and any one of these dimension table?
That will be the day date.
LU underscore day is a table name and day date is a common column, correct?
Yeah.
And even I have this referred as a link between these two with the gray color. So we have a relationship between fact table and LU underscore day. So now I'm going to drop LU underscore day here. I'm going to drop LU underscore day table. Just drop here. Let's see whether we are going to get the relationship or not. And let's see practice. Perfect. So what day date, correct?
Date.
It's taking a lot of time. I mean, there's some issue, but it's correct, right? We have day date column,
Yep.
correct? So the same,
Yep.
so we do have a common column between day center sales is a fact table and this date LU underscore day table. So even I can name it as fact table. Okay. So fact table to day center day table. What is the common column? Day date. So what is the next table we have from day table to? What is the other table we have relationship? What is the other table? This one, right? You have this gray color. This is a relationship, okay?
Month table.
Month table. LU underscore month. Let me drag and drop LU underscore month here. Okay, I'm just dropping here. And we are not sure whether this month table related with fact table or with date table. Okay, let's drop here. Now, what is the common column we are expecting here is month ID.
Month ID.
Perfect. You're getting month ID between day table and month table. Are we getting
Yeah.
the same thing? Month ID is a common column, right?
Mhm.
Yeah.
What is the next relationship? We are done with this one. We are done with this one. We are done with month table. What is the next table we have to pull?
Quarter
Quarter
ID.
table.
Quarter table. So now let's understand how Tableau behaves. Okay, let's understand, because this data is different and whatever the data present in the Access database is a bit different. But let's understand how we are going to establish, how we are going to get the relationship. So when you drop quarter table here, for which table it is going to relate, this quarter table, whether it is going to join with fact table or day table or month table. Whenever you are going to drop quarter table here, so are we going to get relationship between fact and quarter table, or day and quarter, or month and quarter, or which one is the best one? So I want to
Month and
establish
quarter.
month and quarter, right? Let's see whether we are going to get this. That is what the actual requirement. We have to get the relationship between month and quarter, which is a parent and child.
Yeah.
We are able to see the relationship between day table and quarter table. Day table and quarter table. But our expectation is, I want to establish relationship between month and quarter. That is what our expectation. That is what this is. This is child. This is kind of a parent. So we should have a relationship between like month table and quarter table by using quarter ID. But the problem we are facing here is when you drop any table, I mean the quarter table, it's not relating by default to month, it is related to day table. That means how Tableau behaves, let me tell you. Okay, so whenever you are going to drop any table, let's say quarter table, it will check any of the common column present in quarter table and fact table. Understand, right? So first this will check, do we have any common column present in quarter table and fact table? Okay, if you want to check, you can check here. So we have quarter table. In the quarter table, we have quarter date, okay, quarter description, quarter DE, some of the different naming convention, ES, FR, I mean Espan, France, Italy, IT, JA, Japanese, different languages data, okay, Korean language, Portuguese. But importantly, in the quarter table, we have quarter ID and year ID, correct? Okay. But in the fact table, I mean the day center sales table, we don't have quarter ID, year ID, or month ID, correct? We have only day date, correct? Clear all? So we don't have quarter or month or year. We have only day date. So that is the reason why we are able to establish relationship between fact table and day table with using day date. But in the day table, the thing is, do you remember, right? So when I showed you day date table, this one, let me showcase from here, LU underscore day table. Interestingly, in day table, we have all these columns, month ID, We are just referring to month ID, but in general, we have month, quarter, and year. We have all these three, correct? Understand, right? In the database level, in the day table, okay, in the day table, they have month ID, even quarter ID, and also year ID. But I didn't mention here because I don't want to relate day table to quarter directly, day table to year directly. So I just want to go for some proper parent and child relationship. Okay. Clear? But in the database level, we have month ID, quarter ID. So from day table, we have quarter ID, and quarter table, we have quarter ID. That is what we are getting, the relationship between day table and quarter table. But our intention is not to relate with day to quarter, correct? So what I'm going to do is click on this left side. So you're getting quarter ID from quarter table, correct? LU underscore quarter table. But click on this drop down. From which table you have to pick quarter ID? From which table I need to pick quarter ID, whether it is day table or month table? So we have to relate with month table and quarter table, right? This one, month and quarter using quarter ID.
Yeah.
Now click on drop down. In the month table, do we have quarter ID? Let's check.
No.
No, here,
Yes.
yes, quarter ID from LU underscore month, correct? We have.
Yeah.
When you choose quarter ID from month table, automatically this will break the relationship, the existing one, and you can see we are getting proper relationship between month table and quarter table. Now I can see quarter ID is coming from month, quarter ID is coming from quarter table. So if you want to change the join, click on this. Let's say if you want to relate quarter ID from day table, click on quarter ID here. This will break the relationship from month to quarter, and we are getting from day to quarter. So this is not our intention. I want to join the table between month and quarter. So click on the quarter ID, and I have to select quarter ID from month table. Now, what is the other dimension table which we have to pull? So we have day, month, quarter, and what is the other table?
Yeah.
Year table. Same concept, like when you drop year, how this will join. So this will join with the day table because even we have year ID in the day table. Okay. So whenever you're going to join, whenever you're going to drop year table, by default, this will relate with day table and year table. Again, click on this join. I want to establish relationship between year table and so year ID. From which table I need to pick year ID?
The quarter table.
Quarter table. So year ID from quarter table. So now we have a relationship between day to month, month to quarter, and quarter to year. Clear all? I hope you got some better understanding, but still, let me know if you have any questions. So it's not every time direct. Whenever you're going to place the tables, there are cases where this will give you a default, like different like direction of the joins. So we have to understand, let's say my requirement is like to go for proper parent and child relationship. And I want to join from month to quarter and quarter to year instead of going from like day table to quarter and day table to year table. Okay. That is where I have chosen the relationship between the tables, okay, by selecting whatever the columns from particular table. Clear all? Any questions here?
So this one is this will be the snowflake schema, right?
This will be Snowflake. Yes, this is Snowflake schema.
Okay.
So Snowflake schema has multiple relationships. So this is the best example, as I said. Let me give you one screenshot. Okay. So basically, whenever you are going to work with Snowflake schema, we have to understand the parent and child relationship. Okay. But how many tables we do have here overall? How many tables we have?
4 tables.
One fact table is also a table, right? 1, 2, 3, 4, 5. Correct?
Mm.
Clear all? How many tables we have? 5 tables.
Right.
How many joins we will get?
6. Oh no, that would be 4.
You know,
Is it
like,
n-1? Is it the
yes.
same? Yeah.
If you have n tables, remember this concept. Okay, these are the basic things. Okay, I mentioned here, if we have n number of tables, we'll get n-1 joins. So let's say I want to use year and I want to get year wise some sales information. How many joins we are going to get is, like, we are going to get n-1. So that means 4 joins. Okay, so we'll get 4 joins, which is important. So let me showcase the practical. Are we going to get 4 joins? So let's see how many joins we have. 1, 2, 3, and 4. Correct. But I'll showcase a practical example. As you know, the advantage in Tableau, right? You can go back to data, convert to custom SQL. This is only bit. I mean, as I said, this is the only thing which is bit complex. But if you understand the Snowflake schema data model, this helps a lot actually in real time. As I said, you don't work majorly on Snowflake schema kind of a data. But my point here is understand the relationship between the tables. That is what my point. That's what my intention. Okay. So Control Alt, Control C. Let me open Notepad. Now, how many joins we have? So 1, 2, 3, and 4. Correct. So this is 1 join. This is 2 joins. This is 3 joins, and this is 4 joins. Correct. So if you have n tables, we will get n-1 joins. Okay. If we have 5 tables, we will get 4 joins. Now let's understand this way. See, fact table dot day date equal to lu underscore day table dot day date. Correct. Fact table dot day date equal to lu underscore day table dot day date. Is that correct? Understand, right? The first join. Hello. If you're unable to understand, for sure, I'll explain one more time tomorrow. Like, no worries about that. I'll give you a quick recap. Anyhow, you have a you'll get the recordings, so you can go through that. But now let's understand this way, the joins. Okay. See, fact table dot date equal to date table dot date. Is that correct? Fact table dot date equal to date table dot date, right? And what is the next join? Day table dot month ID equal to day table dot month ID equal to month table dot month ID. So what is this join? What is the common column here?
Month ID.
Month ID, right? So this is the join. So this is the join between day table dot month ID equal to, I'll give you the best example here. This is the join here. So this is the join. Day table dot month ID equal to month table dot month ID between these two. Correct? So quarter table, so month table dot quarter ID equal to quarter table dot quarter ID. So this is the common column. So in the third join, so in the fourth join, we have quarter table dot year ID equal to year table dot year ID. Quarter table dot year ID equal to year table dot year ID. So that is what one of the advantage in Tableau, where you can convert into custom SQL. And if you want to modify the SQL, even you can modify, okay? Let's say if you have some unwanted data, like this one, D, ES, some France, Italy, Japanese, some different languages information, right? If you don't want to load this part of data, even you can delete, okay? Remove. So even I will do this, something like that. Okay. You can modify the query. Okay, I'll showcase that. But this is where the importance of Tableau. Okay, so we have you can go back once you convert into custom SQL. Even you can also go back whatever the changes you have done. But let's understand the importance of Snowflake schema. So as I said, Snowflake schema we don't prefer majorly. For Tableau we do prefer star schema. But the understanding of the relationship, that is what the parent and child, and we do have some dimension table to dimension table relationship. Okay, in star schema we don't have dimension table to dimension table relationships, but in Snowflake schema we have a dimension table to dimension table relationship, which is a parent and child relationship. Okay, any questions?
Yeah, Ramesh, quick question. So if let's say you're connecting in Tableau, you're connecting to multiple Excel database or sheets, right?
Yes.
Is there a feature where it can convert that into like a SQL statement, so you can maybe manipulate the query? I know it doesn't like with, I don't, is there a way to, is there a feature to do that?
We can do that. As I said, right, you can not only connect to one data source, okay, even you can add, let's go back to data, you can add a new data source. And let's say I don't have any of the database connections, but you can connect to any of the database, let's say Oracle, provide the details, and you can write a custom SQL as well. You can write a SQL query if you want, or you can pull the tables. And as I said, if you're not expertise in the SQL level, right, we didn't return the SQL, right? You have to go back and go back to data, and you have an option called as convert to custom SQL. If you pull any table, you can also convert to custom SQL.
Oh, so so we can do that for multiple Excel.
Not for Excel, only the limitation is for Excel.
All right. Yeah. Okay. All right. All right. I was thinking that if we have multiple Excel, then and there's a join, then maybe there's a feature that okay, not in Excel. All right. Thank you.
Yeah.
Okay.
We have a flexibility where let me do that. We have a flexibility. You can go for union. So new data source, let's say Excel, some of the Excel file. So you can see drop the table here. Even you can, but even if from union, you can see you're getting the union option below.
Right. Right.
Below you can see union, right? When I
Right.
drop here, yeah. So that will perform union.
Okay.
Okay. So basically you can do union. You can also perform joins. So joins and union is possible. So that is, I mean, but most of the cases we are going to perform joins.
Okay.
Okay. But I'll explain one more time tomorrow. No worries. I'll give you the same quick recap of whatever we done today, and I'll explain tomorrow. So here all.
Yeah, it would be good to explain it, to go over again one more time.
Yeah, no worries. I'll do that tomorrow.
Okay, thanks.
Okay. Yeah, I'll share this and I'll share you the recordings tomorrow for sure. Like, I mean, your morning time, before your morning time, it will be ready and we'll plan. Okay.
Okay. Thank you.
Yeah. Thank you all.